So x is definitely 110 meters. This is number 5 we're looking at. Ernest, what else?
You know the acceleration for x is 0 and acceleration for y is -0.81.
That's always the case. Negative 9.81, I got you. All right. Agreed. What else? George?
50 degrees.
The angle theta is 50 degrees. The angle theta is 50 degrees. Ah. What else? What else? We're done with givens, obviously, now, I think you're noticing. But what else? We have to write something else. What are we looking for is the question. What are we trying to find is the question. Right?
Speed.
What is it?
Speed.
The speed. But give me a variable, Ryan.
The velocity would
V
be.
what?
VI.
VI. Remember, it says the velocity with which it leaves the bat, or the velocity with which it's hit. The initial velocity is what we're looking for. Okay, so we're trying to find out VI. Now remember, VI is not in the x or y direction. VI is just VI. We got to break it up into the x and y direction always to start every problem. So in the x direction, what's V bar? And again, I know I'm writing all over the place, but just try and stay in line with where we are here. V bar x and VI y. What can I write for each of these? What can I write for one of them? Go ahead, Gabe.
V bar x over t.
Well, that's our formula. Yeah, sorry. But what's the, remember the cosine sine stuff? What's the relationship?
Cosine times 50.
Of 50. Okay, times what? What are you forgetting in the beginning there? That's what we're looking for. That's what we're looking for. What are we looking for?
VI.
VI. Remember, it's always VI cos theta for x, for Vx, and VI sine theta for Vy. So we start with that on both sides. Okay? So this is what we're given in this problem. So it looks like right away we're missing VI. And VI is unfortunately missing on this side and this side. Are we given any information about time? No. So we're also missing time. So that's what makes this problem a little bit tricky. We have to solve for two variables here, VI and time. Now, inherently, we don't have to find time. We could substitute and stuff. But in reality, there's two variables that are missing, which is going to make this tricky. If we knew the time, we could have time and x and use V bar x equals x over time and just solve for VI. Right? If I knew what the time was, let me show you what I mean. If I knew what the time was, I could use that equation that Gabe said, which is V bar x. So here's V bar x. Right? V bar x equals x over t. That's the equation I would use in the x direction. V bar x is VI cos 50. X is 110. Well, time is unknown. So I can't solve for VI here. The goal is to figure out what is VI. If time were given in this problem, we could easily find VI from this expression right here. Again, because I'm seeing a few confused looks with this one. Where does this come from? This comes from this. Okay, V bar x equals x over t. This is the formula that we always use in the x direction. And when plugged in for V bar x, which is VI cos theta, for x, which is 110, and t, which is still just t, we can clearly see that there's two missing variables. So there's not enough information to solve in the x direction alone. So where do we move then? If we can't work in the x direction, where should we move? The y direction. In the y direction, we have VI, we have acceleration. We're looking for time. We're looking for time. What else do we know? There's one other piece, and it's really not obvious by looking at this. Imagine you're playing baseball, but it's not at a professional stadium. You don't run.
Is the final velocity 0?
No.
When it comes to a stop?
Remember, VF is always the velocity before impact, or the velocity at a given instant at the end. It's never like after it stops. You always never want to consider it that way, okay? Think about like when it hits the ground, the instant before it actually.
Is y 0?
Why would y be 0 here? The question was, is y 0? Jake?
Because when you're hitting the ball, no matter how far you hit it, it's always going to end up back on the ground.
Yeah, the ball ends up back on the ground. Now, that's why I said not a professional stadium. You notice that? A professional stadium, you hit a ball, where does it end? In the upper deck, right? So it has some delta y value. The batter hits the ball and ends up in the top row of the outfield, obviously delta y. But if I'm playing baseball at like a schoolyard and you hit a home run, it starts here. Here's the fence. It crosses the fence and it ends up on the ground, doesn't it? So the delta y value is 0 in this case. That makes this problem a little bit easier for us. Let's jot that down, please. Y is 0 meters. Okay, y is 0 meters. So in the y direction, I could use this formula. Okay, as always, I'm going to use this formula. When am I not going to use this formula right here? What variable needs to be involved in the problem to not use this formula? What variable needs to be involved, Ryan? VF. Remember, when VF is involved, when you're trying to find the velocity at the end of a problem, or 10 seconds underway, you want to find the velocity, that's VF. Whenever you're looking for VF, you don't use this equation. Okay, this equation is useful when we don't have VF or it's not being searched for. We can plug in what we know. I'm going to move up a little so I have a little more room. For y, we know that's a 0. VIY comes from right above. VI sine 50 right here, that goes in for VIY. T is T still, we don't know what that is. Minus 4.905 T squared. So again, what's the problem here? What's the problem? What do we notice in the y direction? So look at your equation in both the x and y direction. Here's the equation in the x direction we've got. Here's the equation in the y direction. What's the problem with these? They both have two unknowns, both of them. So you can't solve only in the x direction or only in the y direction. What do you have to do to these equations? Combine them using one method from your algebra course when you have two variables and two equations. Substitution method. Okay, substitution method. Unfortunately, we cannot solve for a number here, so we have to solve for a variable. Now, there are several ways to do this. The way that I would probably recommend is the following. Since I'm looking for VI, I want to get rid of time. Does the problem ask for time anywhere? No. So if I solve this equation over here for time, and switch this whole thing with this, I can take an expression for time and replace it here and here. And it'll get rid of time altogether. It'll be everything in terms of VI. So again, I'm going to take this equation here, solve it for time. I'm literally going to flip-flop this with this. Switch those two things underlined in red. You'll get T equals 110 over the quantity VI cos 50. Again, I'm flipping these two locations. Just switch them to get T by itself. Remember, that always works. You can always switch diagonally like that. So this is the expression for T. It really does you no good at this point to even evaluate cosine 50. You can if you want to, honestly. It doesn't matter. But I would take this whole expression and plug it in for T in the y direction. So you're going to take this entire expression for T. You're going to plug it in here and here.
But wouldn't it make it a lot easier to just solve it?
Yeah, if you want to put numbers in, that's fine. Absolutely. Only reason I'm not solving it right now, Jake, is because what if I now say the angle is 45 degrees? I can have an answer when everything's in terms of all those numbers and just change it real quick. But yeah, you could use the numbers. That's fine. So you could do 110 over cosine 50 if you want first. That's fine. You can do that. When I plug it in, it becomes this. In those blanks, in those spots that you see right there, what goes there? Time. And that's that entire expression. So take 110 and substitute it in here. 110 over VI cos 50. And 110 over VI cos 50. So again, I'm taking the expression for time and plugging it in two places, here and here. What happens to VI? What happens to the first occurrence of VI, I should say? Ernest? They cancel out. You look at the first occurrence of VI there. You're going to see VI here, drops off with VI right there. Those two cancel. Numerator, denominator, cancel, cancel. Now, Jake, you asked about numbers. I agree with you now at this point for sure. Here, you have sine 50 times 110 over cosine 50. This itself is a number. definitely get a number for this. Forget solving algebraically now. Sine 50 times 110 over cosine 50, definitely get a number for that at this point. What is sine 50 times 110 over cos 50? What do you end up getting for all that? I want a number. You had a question?
What do we have to cancel out the VI?
The VI has to cancel. Here and here they cancel. But this one does not. This one is still left behind. That's what we're solving for, VI.
131.1.
I'm going to assume he's right until somebody tells me differently. Okay? Now this is the tricky part here. Take a look at the right side, please. Take a look over here. You need to do 110 squared over cosine 50 squared. And then that's going to be VI squared. Remember, this square gets distributed to all three of these. You got to go back to your Algebra 1 math skills. This square term here gets distributed to all three of these because they're all multipliers. They're all factors. If there were a plus sign, it's different. Remember, if this was like VI plus cos 50, this doesn't get distributed to both. But because this squared is here, and these are all multiplying or dividing, each of these becomes squared. So you square 110, you square cosine 50, and you square VI. Is that clear what I'm saying there? So I'm going to write it out for the sake of writing it out just for now, and then I'm going to simplify in the next line. You all see what I'm doing? Take a look if you didn't understand what I said a moment ago. The negative 4.905 stays up top. 110 squared is up top. VI squared is in the bottom. Cos 50 squared is in the bottom. So what I would do if I were you is I would ignore VI squared. Make believe it's not there for a moment. Okay, make believe VI squared is not there. Calculate 4.905 times 110 squared divided by cosine 50 squared. See what that number turns out to be. So again, I'm going to circle what I'm talking about. Please calculate this quantity right here. Calculate that quantity in blue. 4.905 times 110 squared all over cos 50 squared. See what that is? And just put that in the empty spot right here in the next line. The VI squared, just carry it down. Just carry it on down. 110 squared is going to be a very large number. Okay, then you're going to multiply that by a number like 5, which makes it even larger. And then you're going to divide by cosine 50, which is a decimal, which is going to make it even larger. So your answer is going to be a very large number. It's not a coincidence or it's not weird by any means.
Wait,
What do you got, Rap? Hold on one sec.
184,000.
Oh, one at a time. Jana, what'd you get? 63, 159?
I got 74,596.
Oh my lord. We all got, how is it possible? You all could have gotten different numbers.
I got 68,742.
Alright, so clearly I need to check this.
92,000.
Can I borrow this for a sec?
Mr. Al, what happened to the negative 2,000?
The negative gets carried down, it's right here.
No, I mean with negative 4.905.
Look what's happening,
Oh,
guys.
oh, oh,
Multiplication.
okay.
Is that multiplication?
Yeah.
4.905 times 110 squared. This is right here. 4.905 is really over 1, isn't it?
Oh,
So it's like a fraction times a fraction.
Actually, 9, 2, 3.
I got a different answer.
Now you got a different answer?
I got 143,644.
Alright, I'm gonna 143.
No, you should do it.
I'm gonna check. So here's what I'm gonna do. Ready? 4.905 times 110 squared. I'm gonna hit enter just to be safe because I'm not sure about the calculator deeply, right? I hit enter. I get a numerator. I take that answer and I divide it by cosine 50. But I'm not sure how to square cosine 50. So I just hit enter once and then I divide by cosine 50 again. That's how I can divide by cosine 50 squared. 143,644. Okay, if you're really uncertain, put the cos 50 in its own parentheses and square that in the denominator. Okay, but 143,644. Okay, so that number 143644 comes from what's circled here in blue. Not circled, but kind of perimeter.
Yeah.
Now, at this point in time, this is just algebra. Simply take the negative thing, which is this whole fraction, move it over as a positive to this side. Take what you see as a negative, move it over to this side as a positive. So this becomes 143,644 over VI squared equals 131.1. How do I get VI squared by itself now? How do I get VI squared by itself? That's 131.1, by the way. Let me tell you, what do I do?
Multiply the numerator.
Multiply what numerator?
143.
No. Come on, people. This is where I'm noticing you make mistakes in the test. You gotta be careful. This is stuff that's gotta be
That's a
automatic.
comma, right?
That's a decimal. That's a decimal.
No, I'm saying up.
That's not.
Yeah.
Well, just switch the two. Remember, we keep talking about switching? Come on. Whenever there is a fraction equal to something else and your unknown is in the denominator, switch it with this piece. These can always be switched. They can always be switched. So as a result, we're going to get 143,644 over 131.1 equals VI squared. See what that fraction is? Divide those two numbers, please, and then take the square root to get VI. First, you can do it either way. You can do the square root of the whole fraction if you want to use a calculator. It doesn't matter. Some of you are making mistakes in the calculator, so just be careful. If you want to take the square root of both sides now, okay, and the square root and the square cancels, giving us VI. Okay, the square root of whatever that fraction turns out to be. What do you got, Will? I saw your hand pop up.
33.1.
Others agree?
Yeah.
Okay. 33.1. Now, not an easy problem, obviously, right? But the process is what's really important here. If you had a problem with this difficulty level on the test, it would probably take you a solid 10 minutes to go through. So you could expect one with X and Y, maybe not something as difficult as this, where you have to like cancel VI and solve algebraically. You should expect things on the test where you could probably solve for time in one direction and get a number and move it over to the other direction. Probably not having to use a whole expression for time like we just did a moment ago. Okay? But a great problem as an example because it really does cover everything we've been talking about this year. All right, this section for 4.4. He talks about the concept of displacement, the idea of figuring out the actual initial velocity, how it's a function of two components, x and y, cosine and sine. The whole concept of zero displacement for the y direction. What else? I mean, it talks about time being a linking variable, even though we don't really need to solve for time in this problem. Okay?